Okay, so here we are this evening at the Jenks Center. If you're not familiar with the Jenks Center, it is in Winchester, Massachusetts, and we're so thrilled that you're all here this evening. So I'm just going to go over some programming that we have coming up in August. Okay, also let's just do a little bit of housekeeping. You can visit the Jenks Center website and sign up for our e-newsletter. And they also send out a happenings that you can get. Please be advised that this evening, this presentation will be recorded. You did hear that. So if you don't want to be in, you can turn off your camera. We also may ask you to participate in our online survey. That is to meet our requirements for the grant from the Cummings Foundation. So we have, we're so excited. We have so many things happening in August. We'd like to invite you to another race car driver. Alan is going to be here August 3rd. And then we have a Walking Winchester series. We are switching that one up. We're not going to go to the Cyrus Dallin Art Museum. We're going to do the open market and interview everyone there on August 5th. We have Composer's Corner with guest Bonnie McLeod, and that's with Andrew Celentano, who's also the host this evening. And of course, as you know, my fantastic, wonderful husband, and I appreciate him doing this so much. We have budget decorating with Stacy Martin, and that's tips and tricks. We have Eleanor Roosevelt, the First Lady of the World, with Cheryl Fay. She's a one-woman show. She's going to be here August 17th. And all of these events are at 7 o'clock in the evening. We have Stretching for Daily Maintenance, a workshop with John Saya. He's our resident acupuncturist, and he's going to come and show us how to take care of ourselves. Feng Shui Your Space with Mei Hong. She's from the Chinese Culture Connection. She'll be here August 31st. So that brings us to this evening. At first, I'd like to thank the Cummings Foundation for supplying us with an amazing grant over the last 3 years. And we reapplied, and we just received a 10-year grant from them. So we'll be able to continue our online and in-person programs. So we're so excited, and we thank them so much for the generous grant. So that brings us to this evening, car racing with Jim Shaw, and Andrew's going to interview. So Andrew Celentano, my husband, is going to interview Jim Shaw. Jim is an expert at computer-aided engineering, CAE solutions, with a core focus on structural, thermal, and fluids simulations using finite element analysis and computational fluid dynamics. He has worked for Curtiss-Wright, Northrop Grunman, Bowe Bell and Howell, Kodak, and Heidts Automotive Group, which he worked on the design of high-performance automotive chassis and suspension systems. He volunteers with the Society of Automotive Engineers, specifically with the Formula SAE Competition, in which he was a student 20 years ago, and has been a volunteer mentor for the past 6. So through SAE, engages with around 500 students a year, coaching them through the design, analysis, build, and racing of small open-wheel race cars, as well as visiting them on campus to discuss the use of CAE tools for their programs and in preparation for entering the industry after graduation. Jim has raced cars on a variety of tracks, and one of his fondest memories with racing a souped-up Mini Cooper and beating out BMWs. That's awesome. He'll talk about the tracks he's raced on and the cars he's raced with, and we'll find out more about how he goes about racing and the ins and outs of being successful on the track. So that's fantastic. I'm now going to turn over the hosting to Andrew.
Thank you, Hillary.
And thank you so much for being here, Jim and Andrew. I truly appreciate this, and I'm going to turn it over to you now. Thank you.
Thanks so much, Hillary. Appreciate that. You know, Hillary got this job about almost a year ago now. And at the time they said, you know, we want you to put together 5 programs a month, and she put together 15 a month. So she's really aggressively gone after putting these interesting programs together. And they asked for things that were more manly. So we came up with car racing, and that's exciting. And so thank you all. I see some familiar faces out there tonight. I certainly appreciate you coming. I have the pleasure of working with Jim. He's very sharp guy. He does some very complex simulation work. In fact, for one of my clients right now, he's doing an incredibly complex job, you know, analyzing this new medical device that's going to, you know, change the world. Obviously, I mean, all new technology, and it's very involved, you know, technically to figure out how to protect the thermal processes so you get the right temperatures to make sure the readings are 100% correct. It's very involved and of course very important. For the medical world, the FDA approval and all of that. But let me turn it over to Jim now, because Jim, would love to find out more. I know something about your background just from our previous talking, but love to find out how you got into engineering and science in the first place. And then we'll talk about cars, but how did you was there a seminal moment in your life, and we didn't prepare this, so forgive me for doing this, but was there a seminal moment in your life where suddenly you knew, I want to get into engineering? Maybe you won a science fair project, or I don't know. Is there some moment in your life where you just knew this is the right place for you, or how did that come together for you?
Yeah, that's right. No, we didn't practice this, Andrew. So I love the curveball right out of the box. There's a very, very actually specific event when I was in junior high, and I grew up in Exeter, New Hampshire. So just probably about an hour or so north. And I had a math teacher that reached out and said, "You are doing pretty good," and says, "We have a club that we get together after school every day. Would you be interested?" And we do math problems and eat popcorn. And that's my first experience in an after school club was doing math. Wow. And look what happened. That club actually was turned into a math counts team. So I don't know if you've heard of the competition Math Counts, and there'll be an underlying theme, I think, in this conversation about competitivism, competitions, and math and whatnot, and my desire to win at whatever is in front of me. But in 7th and 8th grade, we became first in the state, and I was tied for first as an individual. So it was how many math problems you can do in essentially 30 minutes. It was 30 math problems, and they were, I would say, for a 7th or 8th grader, pretty testing. But I still actually have that. That was my first trophy. That spawned the fire that burns inside me for being very competitive, and I have it on my desk. So I still have my very first, I think my only, for what it's worth, my only trophy. The only thing I ever won happened to be the first thing I tried to win at. The rest is I'm a complete amateur at everything else.
Oh my God, I just think it was math and popcorn. That's so enticing. Math and popcorn after school. I love it. That's great.
That's it. So it was really eye-opening, actually, to do that. So that was fun. And then here we are. What is that? I don't want to say how many decades later, but yeah. And then I end up doing math every day, and I still love it. So
that's great. Well, let's talk a bit about this SAE program, because this is the site itself, folks. So it's SAE.org. And then if you go into the site and drill in a little bit, this happens to show some of the student events. And here you can see, oh my God, I don't know, a couple of dozen race cars that these college kids basically learn how to design and build. Is that true?
Absolutely. Yeah. So this is what we call the college design series, or the collegiate design series. So there's actually a series of events that are sponsored by the Society of Automotive Engineers that students who are typically, I would say the average student is junior or senior in an undergraduate engineering program. And the core is mechanical engineering, but nowadays these machines are, you name it, from mechanical, electrical, software. And the teams that put these cars together, and the competition is around literally designing from scratch. I mean, there is, of course, a rule book, a very many page rule book, but they have a lot of design freedom. So you can see the variety of cars in this picture here. But they choose, in many cases, they don't even get college credit, but they choose to take on this work. And this work is design, fabricate, and go race these cars. And there's two main events in North America every year. The key event is in Michigan in May or June, as it was this past year. We just had it. We just had the main Michigan event a few weeks ago, it's the culmination of, in some cases, 2 years of work. So it's amazing to see the work that these kids are doing. We've got everything from a first-year team of 5 students that are doing all they can to get a car that can even roll a wheel without it falling off, to a sophisticated carbon fiber monocoque, just peak performance with a team of 20 or 30 students, many of which who also compete in go-karts or actual racing. You know, they're in their late teens, early 20s, so they're adults now, and just doing some amazing stuff. But it's actually a trick. The whole thing's a trick, and the students don't get it until they kind of finish the program. The trick is we entice them with racing, right? This looks exciting. It looks amazing. This could be so much fun. The test is, can you work on a team with a unbelievably tough project in an unbelievably short amount of time and push yourself to doing things you've never done before at this point in their career? It hasn't started yet, but in this point as a student, they're just learning the equations in a book. And here they are being tasked. And again, it's almost pure volunteer from their perspective. They don't get paid. Some of them don't even get college credit to drive themselves, to push themselves beyond what they can do, and to watch them overcome challenges. And we, of course, as mentors, help them and guide them along the way without giving them any of the cheating secrets on how to win. It's amazing.
These are colleges all over the United States. Is that true?
So SAE, you can see in the corner there, SAE International. So SAE is an international organization mainly focused on the SAE Collegiate Design Series is focused on North America. The Formula Student, which is an international program, is in a lot of countries. So you've got Formula Student UK, Formula Student Germany, Netherlands, Spain, Italy, India, China, Japan, Australia, South America. It's now everywhere. I mean, the original program was in the late 80s, right out of here in the US. But now it's all over the world. So obviously with travel this past year with COVID, it was challenging, but the Michigan event usually attracts teams from Brazil and South Korea and Germany, and it's amazing to see all the students come together. And the students aren't really competing with each other; they're kind of competing with themselves. It's such a tough challenge, such a tough challenge. So the camaraderie in the paddock, the camaraderie in the pits, the helping. You should hear in the middle of the race, it'll be like, does anyone have a wrench? Who has a socket? Who has this? Like over the loudspeaker system, does anyone have a muffler? I mean, they're really trying to help each other out because you can only be so prepared. So. So what you're showing here, all the different collegiate design series competitions, and you can see it really crosses a lot of disciplines. In this case, we're looking at a couple of the ones that I'm more involved in: Formula SAE, Formula SAE Electric, and Hybrid. So those are electric, internal combustion, and hybrid powertrains, and very, very applicable to today's, what we drive on the street right now is a mix of electric only, hybrid, and internal combustion. And actually, if you scroll up just above the Formula SAE one is the newest one in the bunch, which is the Auto Drive Challenge, which is autonomous. So we have students in their late teens, early 20s that are really developing autonomy in vehicles in the mobility industry. And in a matter of a year or two after this, they're going to go and they're going to do the real thing. So
that's impressive,
the key here is to prepare them for industry so that they're not making the mistakes in industry. They're actually making them as a student, and then they come into the industry, guns blazing, so to speak, ready to go.
Kudos to you, Jim, too, for your involvement as a mentor. You've been doing this now, you said, for 20 years.
Well, I was a student in it, and I was in one of those teams that we were just trying to, we were just trying to get there. We were just trying to get there with a car that rolled, and there was probably 5 or 6 active members, which nowadays is not enough to really field the team. We had a blast. It had a huge, of course, as you can tell, impact on me. And the SAE organization reached out to me while I was at Heidts, and I think we're going to talk about that a little bit. But they had reached out to me and said, "Do I want to mentor?" And I didn't even know that was an option. So 10 years ago, almost 10 years ago, when they reached out to be a mentor, I said, I can't say yes fast enough.
Well, before we get to Heidts, let's talk about what you had on the wall when you were a student. You had, I think these may be some of the cars that you had on the wall.
A little older than that, Andrew, a little older than that. I think there we go. Okay, there we go. There's something a little bit closer. Yeah. I mean, I was definitely into the 70s and 80s cars. I mean, I grew up, I'm an 80s baby, early 80s. But it was Italians, it was German, it was English, Jaguars. I mean, I was just fascinated with anything that looked different and looked fast.
Yeah. You know, we had in college, we had a Saudi prince who tooled around in one of these. I had no idea at the time how expensive it was, but he just had it as a toy for him. It was amazing. Anyway,
yeah.
Let's talk about your time at Heidts, because I think this helped to develop you as an individual. And so you would design these special kinds of suspensions. So tell me how this would work. What would what would a typical consumer be doing with this, and how do they use it?
Yeah, it's a great question. So this right here is actually a front suspension for a 1971 Ford Torino. So the premise here is these are kits that can be installed in the garage by a quote unquote amateur. I will use air quotes amateur, but it really is, they're designed to fit the existing frame. So, starting off literally with Model A's, we had suspension kits that would fit those frames. And you go back far enough and the frames weren't even consistent from year to year, from supplier to supplier, right? If Ford, Ford was doing everything in-house, in the early days, but GM in the early days might have had two different plants, an East Coast and a West Coast, or a Michigan and a California. And many times those frames were different. So these kits are meant to be as close as possible to either a bolt-in or a weld-in solution, depending on if the customer knows how to weld, to be honest. It's meant to be sort of self-fixturing in a way where we provide, a couple of key dimensions to make sure that it goes in the right place. But essentially, this is what you would see in what we call a sort of a resto mod would be the type of build. So what I mean by that is an older car that is being restored, but also modified. And I think the desire here is and every build is different, right? Everyone purchases an older vehicle for sort of different, but also similar reasons. The similar reason is we have an emotion tied to that, right? It's, for me, it would be a Gen 1 Camaro or a Gen 2 Camaro, which, my dad had, or I saw pictures that my dad had that when I was born, he had to get rid of for obvious reasons. It didn't fit a baby seat in the back, right?
Right.
But we all have these emotions tied to the cars that we wanted to buy when we were younger. And now a lot of the industry, the cars are out there on the market. The used car market's crazy. The auctions are crazy. If you ever watch those, Meekums and stuff online. But what we want is something that rides well, right? They're beautiful cars. A 1969 Camaro just is a beautiful shape. Engine isn't perfect. The chassis got 50 years on it. I mean, it's not a car you would want to just sit in the winter and then just expect it to turn on in March or April and then go down to the beach and cruise the strip, right? So we need to have, contemporary suspensions to have a nice ride. And
so in other words, this suspension is
engines.
So in other words, this suspension is definitely better than the original suspension in the car. It's a more souped up or superior suspension. True.
Absolutely. So the suspension design historically has had a couple of key changes, and one of them was what we see here, which is a dual wishbone, or what we call a short arm, long arm. So you can see on the top there's a short sort of A-shaped upper control arm, and a lower but larger A-shaped lower control arm, and then we have a coilover. And in that coilover, that's some of the newer technology. Like Ford Torinos had let's see, probably an old rusty steering box up front, just really, really cheap dampers and springs. But nowadays, everything's got a coilover system. It's adjustable. So if you want to slam it down to the ground because you want to have a low rider. Sure, you can do that. If you want to, put big tires on it and have it jacked up, you can do that too, and so a lot of suspension systems are adjustable to do that.
Now, I was surprised that you told me that there's such a thing as a souped up Mini Cooper. I think this is a picture of some of them. These things are like 300
so
horsepower. Good. These things, and for the size of them, that must have been phenomenal. It's like having a 600 horsepower on a standard car, I would think. It's gotta be amazing.
That was my first and only brand new car, right? You're in your young 20s, and I was an engineer at Northrop Grumman working in the defense industry, and I just was like, time to get rid of my car from high school, and I ended up targeting and getting this Mini Cooper. It was similar to this. I think this is a newer version of mine, but Mini Coopers in general are just so much fun to drive, and they've been around. They originally were successful as rally cars, believe it or not. And awesome. Yeah. So you got a picture, right? So we got a video of an older one there, and it's originally was designed and manufactured in the UK, and then in the early 2000s, is that bouncing around, kind of scary. But the early 2000s, there's another car. We can talk about SUVs.
I did not want an ad to come up with this thing. Sorry about that.
Yeah, this is a great video. So, obviously that's not a stock Mini Cooper.
That thing is tooling. Oh my God, that's just incredible.
Yeah, that's the Goodwood Festival of Speed. It was just a couple weeks ago. It's a hill climb event in the UK. Such a short wheelbase. The car is a go-kart. So low to the ground. It doesn't need a lot of power because it doesn't weigh anything. That car right there, I would estimate to be somewhere around 1,500 pounds, which is about half the weight of a typical, car, typical sort of four-door sedan or something.
How fast is that car going, would you say?
So that track in particular is not designed for really, really high speed. You can see it's a little old school. There's hay bales and there's people standing behind it. And that's not exactly the safety standards that we have at tracks nowadays. But, top end speed for that Mini Cooper, all in, if it was wide open on an open track, my guess would be 120 miles an hour, maybe 130, maybe depending on the gearing. But in this race, maybe 80. Or 75.
It still looked like it was pushing the limits of, for that track. It was really, you could tell he was just at the limits of what he was. If he went any faster, he'd probably go right off into a hay bale or something. So it's amazing. One of the things I want to ask you about is, how do you know when to pull up on the throttle? How do you know when too fast is too fast? We average people in the world that just drive around the highway, we're never hopefully hitting a speed that's out of control. But the whole point of racetrack is to see how close you can get to that point, right?
Absolutely. Get to that point and stay at that point. And so the first question was, how do you know that you're kind of at the limit? And, it's tough to explain sort of in an interview like this. You feel it, right? So now the question becomes, what do you feel? And what are some of the triggers or the feedback that the vehicle's giving you to understand what it's doing or what it's about to do? The key is, of course, to memorize the track that you're on, so you can anticipate the turns and the braking and the turning and the acceleration. But many times you don't get that. In this particular event that we're looking at, you only get one shot. There is no practice run. This is a rally of sorts. There's a start line down at the bottom of the hill and a finish line at the top of the hill. And the key there is, don't push the limits, and people do, and hopefully no one gets hurt. But
well, we're going to see some of that later, so we'll talk about a crash and how to avoid it. Now, this next one is Lime Rock.
Yes, which, Lime Rock. Yep,
is, I think, so another track that you've been to. True.
Yep. In Connecticut, great track. It is equally used by amateurs and professionals, and this to me is.
It's loud. Sorry.
Yeah, that was a little bit of showboat in there, I think.
I don't know where the music's coming from.
This is definitely a social amateur event. You see a wide variety of cars, and you see they're street cars. So these are not, say, professionally prepared. And usually the big difference is it still has an interior. It still has tensioning seatbelts, or maybe it has a harness in there. But the bottom line is they're going to get done with this event, you know, being safe and learning how to drive at the limit, and they're going to drive home on the street. And so the big difference, of course, between, say, street cars and race cars, interior versus or stripped interior, tensioning seatbelts, airbags, lights, blinkers, windshield wipers, and an exhaust that's not too loud. So a lot of and then tires that are not too sticky. So there's a list of things that are on the car that are controlled by the Department of Transportation, DOT. And when you build a race car for sole racing purposes, all of that gets removed in the sake of weight and performance. Remove the weight. A lot of times the windshield gets removed and replaced with a sort of a Lexan plastic or something.
Really?
So,
I did not know that. Wow.
Yep. So
now this is another track, I think. Let's see, which one is this? This is Goodwood, the Goodwood Festival. This actually is a very interesting one because you have a lot of different, everything from Model Ts up to everything, right? So we'll show a little bit of this.
In order to do a bit of shuffling of cars.
I believe there was a cracked block that led to changing of vehicle. But,
the clutches are a little rough back in the day, I think.
Yeah.
Of course, they're sitting atop rather than within.
So I think this is a Mercedes, 60 horsepower.
The Mercedes,
Beautiful.
60 horsepower, George Wingard at the wheel. Now, don't expect this to be the fastest time of the day, far from it. Do not expect
I love
it
the
to be
commentary.
Remember, this car dates back to 1903, 60 horsepower, but it was still able to do impressive top speeds and average speeds, and this is how it would have been apart from the full face helmets. In other words, a riding mechanic, the driver working hard.
So back
the wheel,
then, which was
forget
interesting.
seatbelts, forget roll cages, forget safety in a sense in that period. Forget even a
Go ahead. Yeah.
It was really, you know, it was dangerous, you know, and that attracted a lot of people. The excitement nowadays is much safer, but the excitement still attracts everyone, the adrenaline rush. In this case, one of the big key differences here, of course, you have probably a very heavy vehicle with only 60 horsepower, which would have been a lot for 1903. Mercedes at the time was at probably peak performance in regards to power output. The other key difference here, of course, is the tires. So these tires are nothing like what we have nowadays. So nowadays we have what we call steel belt radials. So there's a steel belt that is molded into the tire. And that steel wall provides stiffness as the car wants to slide or roll. The sidewall of the tire is kind of stopping you from leaning over, and it keeps the tread stuck to the ground. This is a completely different tire, completely different situation. You can see the tires are actually pointed out. We call that positive camber, and these tires were designed for positive camber. Here's another example of using those old style tires before we knew how to really manufacture and make.
By the way, this reminds me of a famous movie. The title, I can't remember the movie. When I was a kid, I was watching. Mickey Rooney was in a movie racing these kinds of cars, and he was in a big accident or something. I forget the name of the movie, but it was as a kid that made a big impression on me.
Yeah, I look at these with the engineering hat on. It's hard not to. Yeah. And it's fun to see some of these cars that are, from the 20s, 30s, teens, and over 100 years old. There's so much we didn't know, and it was so trial and error. Like the rear shape of that would have been someone's attempt for aerodynamics, and if you can map car racing with the aerospace and flight physics that we understood at the time, it was just the Wild West. We didn't know. We had no idea what we were doing.
By the way, I'm sorry to interrupt, but there's a big thunderstorm that just came in over my head. So if we lose on this end, you'll still be hosting the meeting. So maybe you can just go from there. But I wanted to say that one of the things that impressed me about when you talked earlier about the wheels deliberately being, what did you call it, cambered out like this?
Positive camber, yep.
What is the benefit of that? If you can explain in layman terms, why would you want to do that?
So in general, the science, if you will, of suspension design is to, as the car rolls, as it turns, as it moves around the track or around the road, is to keep the tire and the tire tread specifically in contact, in optimum contact, or the best contact. So nowadays, we have wide tires are crazy. They can be like a foot wide on race cars, just crazy. Yeah. You can see here that there's a very, very small, what we call a contact patch, very, very small amount of area of the tire that's touching the ground compared to how big the tire is.
Right.
And the way that that was shaped, you can see almost a profile, almost had a kind of a rounded profile. The way it was shaped, turns out, it had more grip when it was pointed out, as they found out. Again, this was all trial and error. The theory of kinematics and dynamics and the sciences and arts that we have now of how to design a car suspension was
I think I've still seen some soup cup cars on the road that their tires look like out of alignment, but that's deliberately done.
Oh yeah,
so, yeah.
Well, there are some trends nowadays that you see in the street of them being very, very low and very, very sort of cambered, negative camber. That's really a style more for aesthetics. It's not for performance.
I was wondering if the negative camber would make it more stable in terms of lateral motion. No, does that not make sense?
There is a narrow band that you would want to be in, and if you can see it on the road very, very blatantly, it's usually way outside that sort of narrow band of performance. Yeah, we're talking just a couple degrees, maybe say up to 5 degrees of what we would call negative camber. But there's stuff on the, you see some of those modified cars now that are just like 45 degrees. It looks crazy.
Now this goes on for 40 minutes, but I thought I might just jump ahead. Maybe this is the style that Mickey Rooney was driving with the, yeah. I'm going to jump ahead a little bit and see the different styles.
Oh, there we go. So that's the
Mustang.
The new Ford EV Mustang SUV. And the EV cars are really, really interesting nowadays. So they have a huge battery pack, a very, very large and heavy battery pack, but it's down in the bottom of the vehicle, underneath you. It's underneath the floor pan, underneath the seats. That lowers the center of gravity, and that makes the cars very, very well handling. So I'm sure you've seen a Tesla on the racetrack. There's all kinds of videos out there now, and they can be very, very competitive.
I never thought of that. So the fact that they're so low, the center of gravity is so low because of the battery location, where the engine has to be higher because it takes up space vertically. So that's pretty cool. Yeah.
Race car builders have been trying to lower the engine in the car since they first tried to race it. And as the joke goes, the first car race was the day the second car was built.
Love it.
Yeah, what a beautiful, look at this. There's a 250 GT Ferrari short wheelbase. What a beautiful. They call it the bread van because of the back. Yeah, it's amazing. In other forms, we might have called it a fastback, but more of a bread van. It's meant to actually be more aerodynamic. And again, this was back. I mean, this was back when we still didn't really fully understand aerodynamics. 50s. And 60s, 70s is when we started to get dangerous, and then in the 80s we finally got it kind of all figured out and got a bit safer.
Now with the foil in the back, this obviously is helping hug the road, right? The whole purpose is to keep the rear wheels down, I believe.
Yep. So yeah, exactly. So you can see that wing is trimmed back quite a bit. It's not a real high angle of attack. So in this case, that particular person who tuned that would have been expecting pretty high speed, and they didn't want to, if you have the air, if you have the wing tilted up, you're going to get some drag as well. So, here we have some looks like some rally cars. So these are going to look a little bit more like sedans. Oh no, it's a touring car. So this would be from a GT series, but beautiful.
Now it's interesting, from this angle, you can see every little nuance of a turn and adjustment as they make it. It almost looks like they're losing control or fishtailing a little bit, but it's probably just the way you see a little bit of a wiggle there, but just kind of maintaining their grip on the road, I imagine, right?
Yeah. I mean, usually it's not, it does look a little skittish. It looks like it's trying to kind of get pulled a little bit. It could just be a very aggressive suspension tuning on the car. But what's unique about this event, this Goodwood Festival of Speed, is it's a huge variety of cars. It's cars, you've just seen them from many different eras. Some of these cars are in their original form when they won, say, a World Rally Series or a World GT Series. These cars are all probably worth, on average, $500,000. I'm just throwing a number out there. These are, former, championship winning vehicles that are, for the most part, typically sitting in a garage somewhere, staying clean and staying safe, and then they pull them out one day a year in this event to let it breathe, so to speak.
Wow.
Yep.
skipping that again.
Yep.
Oh, that's something that happened.
Yeah, I heard about this. That's a NASCAR chassis that someone had on there, and it looks like they got a little out of control. So yeah, did a little bit of damage on that one. That's going to take a little while to fix.
Yeah.
The good news is, A, no one got hurt. B, it's just body damage. Body damage can get fixed as long as the frame isn't bent too much. So these cars are built to withstand impact and withstand a lot of vibrations and fatigue. I mean, these cars will run, say, 10 weekends a year, and each weekend they can run hundreds of laps. So
I have to tell you, watching the driver view, that was not sped up. That's the actual speed that they're going at. It looks like almost impossible to. How do you make a turn and make sure you have to really know the track, I think, to be that aggressive, I would imagine.
Yeah, the proximity to the hay bales makes it seem a lot faster too, and the brick wall. Let's be honest, next to a brick wall like that. I think that the key to speed for these types of drivers, obviously, if they've been to the track in years past, you're going to have an advantage if you know the turns and where they are. You can brake a little bit later. You can trust a turn where you can't see the other side of the turn. If you're a novice driver on a new track, you really have to be cautious. The cost of being wrong is potentially getting hurt. So you have to be careful there. But a good driver who is in a car that they know, and I think that's really important as well, is that they know what the car can do. They know how to push the car, and they know how to feel the car when it's starting to, do something it doesn't want to do. That's it. There's no way to get faster with the right driver and the right car, right conditions.
Well, we have another couple of racetracks to look at, but I just wanted to kind of get a grip on, get a little bit of a read on each of the key cars that they were driving in this event. So. Yep.
Okay. Those are all professional drivers and professional cars on a novice track. If I can say that track is actually, I think, an access road at a private. It's at a private property in the UK. It's a kind of they call it. It's a festival. It's once a year. There's a festival of speed. It's on my bucket list. I have not been yet, and I don't need to drive. I don't need to be behind the wheel, but it sure will be fun. I'd be okay just staying behind a couple hay bales.
You were talking about knowing the track, and I have a couple of examples here that we reviewed. So here's a case where they're actually explaining to you what to do at
coming into one track. You're going to crest a small hill. There's brake markers here. Typically you're going to brake right around the very top of the hill, maybe a little bit before. As you go throughout your track day, work your way up to that corner. It's very tricky because your car will get light coming over that little hill. And you're going to kind of early apex from what you think, because you kind of come up to it thinking it's a 90-degree corner. It's not. Cut the curbing on the left on the inside and power out of it. And you are going to enter two slightly on the left side of the track. And you're going to work on that late apex and getting on throttle. You're actually kind of coming up a slight hill here. And then you're going to hug it on the end. Make sure you get on power soon enough and carry it down into 3. 3 is a hard brake zone, kind of a double apex, perhaps a double apex, I should say. You're not going to actually use that first apex. You're going to look at the
So this is a local track to me
point.
here.
Turn in a little bit late
away from me.
And get on throttle. Lots of space and runoff here on the exit, so you can really get out there if you need.
So this is local to you.
This is local, yeah. So this is a track I've been to dozen plus times, and this is a great explanation of how to navigate the track. To the audience is expected to not have been there before or only have been there a few times, and what the instructor here is describing is essentially where to be on the track laterally, to the right hand side, to the left hand side. As they go around the track, we call that the line. So that's just generically called the line. And every track and car combination has the line, the infamous line, the line, the fastest way around the track. Every car track combination and weather combination and all the variables that go in, there's always this line that you're looking for. That's you're in the internal search for the best line given a track and given the conditions in the vehicle. And what he's doing is telling the class or whoever the audience is how to approach the turns, where to put the car. And in the early days of just learning how to drive, it's just being comfortable with being precise, I think would be the way I would describe it. Being comfortable with being precise. You need to be precise. You need to know where you are laterally on the track. Is your right tire up on the edge of the asphalt? Are you a tire within? Are you half a tire within? It's a very, very precise sort of learning and sort of discipline, I should say. So a lot of times we are really trying to put the car in the right location within an inch. At 100 plus miles an hour.
Yeah. What do they mean when they talk about the apex?
That's a great. I don't know if you want. Maybe you want to turn the audio off. I'm getting a bit of kind of an audio jumble there.
Yeah.
Yeah, I don't know. The audio is getting a little.
Sure.
So the apex is the point on a turn where the car is going to be as close as possible to the inside of the turn. Mm-hmm. And in many, many cases, the theory of it is for a given radius, and let's look at turn number 1 right there. It looks kind of like almost a 90. It's not quite a 90. I'd probably call it more like maybe like an 80-degree turn, a little bit less. And you might look at that turn and say, what's the largest possible radius that I can fit given the width of the track? I start on the right-hand side of the track. As I go through the turn, I'll move towards the left, and then I will then come back out to the right-hand side. Yeah. And so, the theory is what's the largest radius I can fit on the track given its geometry. But when you start to factor in the type of vehicle you have, and I don't know if you heard, but he was actually talking about elevation changes. And track maps are great for sort of understanding where the line is and communicating, hey, you want to be over here, here's your braking zone, here's where you accelerate. But the track maps typically don't have elevation on it. So, you can look at a whiteboard like we are now and watch a video, but nothing's like getting out there. And you look at the track differently. I look at the track through a windshield, and part of my view is blocked by the steering wheel and through the dashboard. So it really is, there's a perfect example, right? So this is as close as we can get to a kind of a bird's eye view or a sort of a point of view of the driver. This is totally different, and that's on Gingerman. This looks nothing like what we just sort of were memorizing from the track map. So
this is exactly the track he was just describing, and now this is the actual view in the vehicle itself.
He's coming up to turn 1, so he's going to turn left, hit the apex. He's going to come out not all the way to the right. He's going to try to stay to the left a little bit, and then he's going to come in, and the guy was saying late apex, so he's going to slowly roll into the right apex, and then he should open up the steering wheel now and come onto the left. So a key number 1, find out where that line is. And the easiest way to find out the line is talk to somebody who's raced the track before and talk to them, particularly somebody who has a car like yours or similar to yours, because every car is different. A heavy rear-wheeled power car is going to want a slightly different line than a souped-up Mini Cooper, which is front-wheel drive and short wheelbase and lightweight. So once you get comfortable with the line, then you can get comfortable with the car and you can push it. And what we push is the points on the track. So there's a point that we start to brake for a given turn. There's a point with which we turn in, a point with which we allow the car to come out, and a point with which we start to accelerate again. And so once you've memorized the line, once you're comfortable sort of in the car, then you start to move those points. You brake later and later. You get back on the gas earlier and earlier. And once you've memorized the track, you can really start to push the car and push yourself.
I'm just going to play all of this now with the sound, just to get the feel of that of the drive itself. Let's say I first got to find it. Here we go.
Yeah, let's do it. Yep.
Curbing on the left, you can really run over that curbing. Enter the turn 2 somewhat in the middle and turn in. This corner is increasing radius, so it does open up, so you can get on throttle pretty quickly and let the car push out. Late brake into 3, and this is actually a 120-degree-ish corner, so don't turn in too early. Use all that curbing on the left. Turn 4 is flat, should not have to lift. Coming into the 5-6, you get an early apex. Point out to the edge of the track there, then back in. So kind of make it a V. Coming into 7 here, you're going to early apex. Don't worry about the exit because you end up wanting to stay on the left side of the track anyways. Stay out, 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 then turn it in and try to carry the momentum here through the 8-9 complex.
Now, one of the things I noticed is that there were times when he kind of oversteered and then went back like pretty quickly. Is that just because the linkage is such that it's a little bit it's not perfectly tight? I would think it'd be pretty tight, but this almost looked like or is that because he overcorrected, had to overcorrect?
Yep. So let's assume for a second that the car is well prepared and all of the suspension should be tight. There should be absolutely no play in the steering wheel or in the, any sort of linkages. So what you're seeing there is the tires typically will roll. And as we start to push the limit of the car, we will actually let the tires do a combination of rolling and sliding. And a good race car driver will always be some combination of rolling and sliding. And the reason that is if you're only rolling, you're leaving speed on the table. What I mean by that is you can go faster through the turn. If you go too fast through the turn, you will slide without rolling. And you've seen cars like that where they just kind of slide off the track, or there's that Corvette in a few videos ago where the back of the car was just swinging around and the rear tires were sliding. They weren't rolling or anything. So you're trying to play this very careful balance with rolling and sliding. And when you see that, and we call it sometimes a seesaw, and it is usually evidence of a learning driver is trying to plane in that zone. If I'm trying to turn to the right for me here, I don't know if it's left on the video, but I'm turning to the right. And once I get to the limit, I'm going to start sliding out. When you start to slide too much, you feel it in the steering wheel. The steering wheel will start to get light because it's almost like you're on ice because you're sliding. And so if you're either not ready for that, or if the car is tuned really, really funky, you end up kind of fighting it a little bit. So it's, I don't want to come across as being too critical to this driver. That person probably has more experience on this track than I do, and I'm not quite sure what kind of car that is. But when you see a kind of a car driver doing this, they're really at the edge, and they're really balancing that sort of sliding and rolling with the tire. So
okay, here's another one. This is a Super K fastest lap from Gingerman Raceway. So this should be fun to watch.
Oh, we can see a nice, good hot lap here.
Yeah. So here you can see the monitoring of the RPM and the speed.
Yep. So on the upper left, we have a track map that shows the green section would be where the gas is being applied, and the red section is where the brake is applied, where the turns are.
Okay.
In the bottom left, you see what we call a G map or a GG map. So we have a red dot that's traveling at a right now 0.8, 0.5 G's of acceleration. And under braking, it'll go forward. Under acceleration, it'll go back. As it turns, it'll go around. It's a great tool to show that this person's quite smooth. That ball should be moving nice and smooth around that map, from acceleration to braking to turning. In the bottom left, we have the position of the gas and the throttle. So you can see that this person is, I believe, left foot. I'm not quite sure. It's interesting. I think maybe that's just the brake pedal just kind of bouncing around there. But those green and red should go up to 100 when it's full gas throttle and full brake throttle. I'm wondering if there isn't just a tuning. Oh, there we go, 96, 90. Okay, full throttle. This must be a very fast car, because Gingerman can be a tight course if for very fast cars. But you can see here he's at 100% there.
Yeah, he was going 140 miles an hour. I have to tell you, I'm getting weak knee just watching this. Because it's on the big screen here, and I feel like I'm in the car. What's this at the bottom here? It looks like it's mapping out something over time. Is that the throttle basically up and down?
That is, yep. So that my presumption is going to be either the throttle or the velocity as a rolling window, depending on kind of what we're looking at there. So those are all tools that fall under a category we call data acquisition, and it's not any easier. I don't know. You could ask somebody who's been racing for a long time. I don't find it any easier to learn racing now. I think it's still challenging. The cars are even more advanced, but there's more tools. And there are more ways to get on track if you're an amateur. And for that reason, I think it we're seeing more people racing cars, and hopefully more people who understand cars and car control, and hopefully it results to safer streets. But the act of learning how to drive a car at its limits of adhesion is not any easier today than it was. You've got more data, more measurement. I mean, we've got an accelerometer in our phone right now that you can just Velcro onto your dashboard, and you can get the G accelerations, and you can get some data that, 20 years ago, would have cost us a lot of money. So there's
Actually,
a lot of sensors.
My wife is my accelerator notification. She says, "You're going too fast." I get that. So here's another track. This is Jim Paci on a Porsche 911.
Yeah.
And so this is probably a good one to watch for a few minutes. This is my wife's view of how I drive.
Sebring is crazy. I've been there. It's a lot of fun.
I like his rearview mirror. I could use one of those.
So that you don't, no one's in your blind spot. There are no blind spots with that mirror.
No blind spots.
No. Yeah. Compare that mirror up top to the little side view mirror on the bottom right of the screen. You can't see anything in that.
Yeah.
This guy is driving very aggressively. Yeah. This also looks like a track day. So you have a variety of cars. There's a Lotus. I think he passed a Porsche. He's driving them. He's passing them very high rate of speed. So he's very comfortable in the car, very comfortable on the track. This car is definitely well prepared. It just looks clean, and not the first time this car's been on this track, I don't think. You can see how bumpy this track is. Sebring is, Sebring is just it's murder on your tires and your body. You're I'm sure you've been on the car for a long car ride, right? And we talk about fatigue. Truck drivers is a concern, right? They drive for more than 8 hours. Yeah, you drive in a car like this on Sebring for more than an hour and a half, and it feels like you've been in the car for 10.
I was gonna say it's like a workout. Yeah.
It is. Let me see if there's I don't know what the G map looks like here, but in very, very high performing cars like Formula 1, IndyCar, you specifically work out your neck, because your head is basically an 8-pound bowling ball sitting on top of your neck, and you go out there and you feel 2, 3, 4 lateral G's in some of those really, really high performing cars, and you have to have strong neck muscles.
Speaking of which, you might want to show us your helmet, because you have a support there, right? What do you have going on there? Yeah,
so I have a pretty standard device that we use nowadays. It's called a Hans device. So I don't know if you can kind of see that there. And this is a device that Hans stands for Head and Neck Restraint System. So head and neck system. So what it goes is it happens to sit around your neck on your shoulders, and you can see it's quite flush. There's some padding underneath. It's very, very stiff, lightweight material, typically a composite. And you can see that it's my head, and I don't have my helmet on here. I wouldn't be able to fit my mic in it. But what happens is I will clip the sides of my helmet, and there's 2 loops here, and they will clip to the side of the helmet. You can see I've got a few sort of loops here that I might connect to. That is to keep my head from moving sideways and forward in a crash. So the 2 most common crashes that you would see are a frontal collision, where your neck would go forward. So my neck would go this way. And if this is connected to the side of my helmet, I'm just going to come here and stop. And there's an angle between my neck and my spine that it's going to keep within that angle, keep it safe. If it goes too far forward, you get hurt. And then also from side to side. So the second most common impact would be a T-bone situation, where 2 cars are racing, something happens, a car comes sideways and another car hits. So it really does protect your head and your neck from moving too far away, and controls basically the angle of your vertebrae. I want to say it's a couple decades old. This is an older one. This is not a fancy carbon fiber one, which is even lighter and stronger than this. But it is a standard safety device for even the lowest, I say lowest, even the most earliest and amateur form of racing requires this without a doubt.
Wow.
It is it requires a little bit of getting used to. So when I first started learning how to race, I had a helmet, and the Hans device wasn't really required, and I didn't have one yet. And you can turn your head and you can look through those blind spots that we were seeing in that Porsche. But when you have the Hans device connected to the helmet, you're very limited, and you have to learn how to use your eyes to look in your peripheral as opposed to your neck, like we may be used to on the street. So this is absolutely 100% a lifesaver.
Yeah. Well, you know, we didn't script this, but now maybe this is the best time to actually look at that crash.
Sure. Yeah. Let's take a peek real quick.
So let's take a look at this crash, because this was let me get out of this one. This is okay, this is the wrong one. Hang on a second. Let me get out of this and get to called Big Crash, and this is on YouTube. So I'm going to turn this on. I actually skipped ahead a bit. I don't want to take up too much time, but you'll see coming around this turn what happens, and then you can kind of what did he do wrong?
So notice the Hans device connection next to his helmet.
Yeah, exactly.
So, you know, you can see, you know, thankfully this driver.
Let me see if I can get back there without it going off again. And luckily he's okay. The guy's talking to him.
Yep.
Yeah, you can see that device around here. Sure.
Now you can also see here, this appears to be the first or second impact on the roof, but notice how close his head is to the top of the car.
Right.
Belts are designed to stretch, and part of the belt stretching is what reduces the acceleration or the deceleration that we feel as a driver. So if the belts were 100% rigid and the car hits a wall at 20 Gs, we're going to feel 20 Gs, and our bodies are not designed to feel 20 Gs. So the seat that you sit in is rigid, but the belts that strap you in are allowed to stretch. Well, what a lot of people don't realize is that means you're going to slide up. They should be very, very snug around your hips, but they are going to stretch a little bit, and you can see that here. And a lot of rules for tech inspection. I'm putting my tech inspector hat on now, since I was a tech inspector at the Michigan event a few weeks ago. Is measuring the distance between the roof of the vehicle, or in the case of the small SAE cars, we put a broomstick, between the main hoop and the front hoop, and we measure the distance between that broomstick and your helmet to allow room. We need a couple inches in there to allow that. So we can see that those couple inches, I don't think it's touching, but it is, it's scary. You do not want to touch the ground with your helmet. This is turn one. Do you want to talk about the turn, or do you?
Yeah, let's talk about what he did wrong here.
Right.
So it looks like he went too far to the right and hit the
right here.
Whatever. Yeah.
So there's a couple of things happening. The first thing I noticed, if you want to roll back to before the turn, so if we just pause it here for a second,
sure.
One of the things that when you showed me this video and said, hey, is this something we could talk about? I said, there's definitely a couple of things I could pick out. First off, this is a Mini Cooper.
Okay.
I recognize the dashboard and some of the interior features. And so I recognize that. So I commend this person. You can tell that it's stripped a little bit. There's no interior in the roof. They've replaced the glass, thankfully, because that glass would have shattered during the rollover. But however, and you can almost see here, so one of the things that I have a little bit of just sort of criticism for this driver is notice where the hands are located on the steering wheel. I know that they teach us when we learn how to drive to put our hands at 10 and 2, and that is probably the best location for driving. It gives you the combination of control and maybe comfort, but it's not the best for a race car. You really should be right at 9 and 3 without a doubt. And the reason is if I sit, I don't know if you can see my video here, see my screen. So as I sit in a car and this gets into a little bit of ergonomics and race car sort of seat and steering wheel design. As I sit in a car, I really want to have my forearm just about parallel with the ground. And so I'll adjust my seat height accordingly, and I'll make sure my steering wheel is at 9 3. What that does is it allows me, and it allows the muscles in my arm to get maximum torque as I can torque over. If I'm up high, okay, you can see I'm already raising my shoulders up a little high.
Right.
And now I'm trying to come over. I'm now using all kinds of other muscles. So fatigue is going to set in, number one. And number two, I don't want to use my whole upper body to race the car. I want to use my shoulders. I want to use my arms. I want to be set back into my seat for safety. And I want to hold at 9 3. And I don't really want to cross over, right? So a lot of steering is designed to maybe come up to 12, maybe just a touch over, no more. He had his hands at 10 2. And what happens is, as you're driving, you will come over center. And if you're watching right now, Andrew, if you just try it, have your one arm go over center, you can feel a whole nother set of muscles in your shoulder.
Yeah.
And it's not the best. It's not the best for control.
It's hard to leverage back. Yeah.
Hard to leverage back. Yeah. So that was the first thing I noticed when you sent me that picture. When you sent me that, or sent me that video, I said, I think his hands are a little high. Yeah. The other thing is, let's get back to, so this is about, so you can see right here, this is what we call at the track out. So a turn will have, say, 3 points, let's say a turn in, which is when you turn into the apex. The apex, which is where, say, in his case, the left wheels would have just hit the inside of the curbing, and then the track out, and the track out comes all the way to the other side, and now the right-hand side. So basically, and there's these rumble strips. So the right-hand side of the car is in the rumble strip, say, in the braking zone. Then the left hand of the car hits the rumble strips at the apex, and then the right hand of the car hits the rumble strips again on the track out. Now, in this picture, you can even see there's quite a bit of grass missing on the track out.
Yeah.
And there is a gray area in racing, and that is how much of the car is allowed to go off course. And if anyone here follows Formula One or any of the road racing events, there's almost every race, there's are they using too much track out? Are they allowing the car to go too far wide? And the car is faster because, as I mentioned before, the radius to go through the turn could get bigger. You could go a little bit faster. What I think happened here, and you can even hear the front tires start to understeer. The car naturally understeers, so that means the front tires are going to be, sliding a little bit more than the rear. So it sounded like he might have been kind of fighting the front end a little bit. And as the car was kind of sliding out, it appears he drops the two right tires off, and I mean dropping off like over the rumble strips and into the dirt. And
are you supposed to hit the rumble strip at all?
Oh yeah. The rumble strip is in play, baby. Absolutely.
How does that help? I think that would slow down the racer. Help me with that. Doesn't it bounce up and down, or what is the rumble strip exactly?
So, great question. So, at a big picture, if you look at the map, if you remember that picture of Gingerman, I was looking at turn one. If I've got a very narrow track, okay, and it's only, say, one car width wide, I can't fit a large radius. But if my track is really wide, I can fit a larger radius. My line becomes a little bit larger because I'm starting over here, I'm apexing here, I'm starting over here. You end up kind of going across the entire track, larger radius, faster car, slow, lower lap time. So you're always at the limit of the width of the track. And so you're always kind of there. Now, the rumble strips are there for a few reasons. One, to kind of keep you. Sometimes they have a little bit of tilt to them. And so they will kind of keep you from going all the way out. Number one. Number two, it is defining the edge of the track. So you're not supposed to go over the rumble strips. Some rumble strips are so aggressive that if you go over them, they will actually hit the bottom of your car. And those are sometimes there on purpose to physically deter the racer from doing it. You can tell a racer anything you want, but what the racer decides to do out on track is what the racer decides to do. And if no one's watching, they'll do whatever they can to win a race. But so sometimes you have to design those rumble strips, or sometimes we call them gators, because they kind of resemble just a gator tail, just so aggressively that it just will hit the bottom of the car, which is also dangerous and potentially damaging.
So if hitting the rumble strip wasn't wrong, what was wrong? What did he do
Yep. So it looks like he actually went past the rumble strip.
Yeah,
and as soon as you go over, now the rumble strip has obviously a different surface to it. Some of them are stickier than the track surface. Some of them are less sticky. It all depends on what it's made out of versus the track. You know, Sebring was concrete. This is asphalt. It depends on the tire. This is suspension. There's a lot happening. But once you get past that, this red and white striping here, it's dirt. And we can't see his dash here, but roughly, let's say he's going around 65, 75 miles an hour. Imagine going down the highway and then all of a sudden hitting a patch of dirt. Right. It is not fun. And in this case, half of his car was in the dirt and half of his car was not. And when that happens, and I have literally done that same thing on the same turn, that left-hand turn is faster than it looks. The video doesn't do it justice. You don't really brake for that turn. You kind of lift, and that's about it. And you lift, you get the turn set, and then you roll right back on the gas. And you really are just kind of riding that car through this turn. It's it's actually quite a long turn, kind of a sweeping turn. A little bit, not an elevation change, a little bit of camber change.
So you hit the rumble strips on this track, right?
I hit the rumble strips, and I even went into the dirt and the grass. The key to surviving this, and when I say survive, I just mean making sure the car continues down its trajectory.
Not crashing.
Not crashing. Yeah, exactly. Avoiding the impact by all costs, and if possible, don't slow the car down. When you slide the car out and you have one set of tires on one surface that is slippery and another set of tire that is in sticky, the last thing you want to do is touch anything. Don't touch the brake pedal. Don't touch the gas pedal. Don't even touch the steering wheel.
It's like hitting ice.
Yeah, but you're half on, half off. That's the whole thing. Wow. You know, if you were fully in the grass, of course, you're on ice and you're really limited with what you can do. When you're half on, what happens is you still think you're on the track because the driver never left the track. From his perspective, he never went in the grass. But you got to know that just because you're physically not sitting over the grass, the car could be in the grass or in the dirt, in which case it was. I think what happened was he tried to steer back on. And when you do that, you got your two front tires and you go to turn it one way. This tire has grip. This tire does not. So what ends up happening is this tire will slide in the dirt and the rear tire will rotate around. And this front tire, which has all the grip in the world, will pull the nose in. And you can see what happens is that the car just does this. And I would say that once the car lost, he lost control of the car. He didn't really do anything. That's probably for the better. It was a head-on collision before the rollover, more of a front right collision, and the car is much, much, much safer hitting head-on than it is hitting in any other direction. Cars nowadays are designed to absorb a lot of energy in the front. Believe it or not, and full circle, Andrew, a lot of these cars' safety features were designed in simulation on the computer, but many cars nowadays are designed where as soon as you impact the front bumper, the way that the front crumple zone will start to buckle, the motor mounts will actually break on purpose. Wow. And the engine will actually drop out of the car and onto the ground. And you might think that that's, terrible. Well, what's good about that is the engine is a mass block of material. You don't want that black block of material being pushed by the fence into the dashboard and into the cockpit.
So the driver goes over it basically.
Well, the whole front end of the car will just start to crumple. And I know we don't want the cars to get damaged, but if the cars got damaged less, then the drivers would get damaged more. When you have an impact, something has to bend and break and what we call absorb energy. We want the car to absorb as much energy as possible so the driver doesn't absorb any. And that's
I love the way you got simulation back in the conversation, Jim.
Like I said, I started doing math many years ago. I can't get away from it.
That's great. Well, Jim, we could talk for a whole other hour, but we've passed our time. Thank you so much for this time. I did get a message from, in fact, my brother. Thank you, Dennis, that the name of the show was The Big Wheel. I guess the movie is called The Big Wheel.
The Big Wheel.
And I'm just wondering at this point, we can open to the floor if there's any questions. I'm going to just turn this back and put you in the spotlight now. So let me stop sharing here. So does anyone have a question at this point? We can unmute and ask your question directly. Nate, by the way, is a nephew of mine that's been a big car enthusiast for a long time. I'm really glad he showed up.
Oh, you're welcome, Nate.
Yeah. Dennis, any other questions from you?
Yeah, I think, wasn't Paul Newman had started his racing career late in his life? Is it too
really?
late for me to start my racing career?
It's never too late, Dennis. Paul Newman was amazing. I mean, what you know, there's a guy who you couldn't tell him he couldn't do anything, you know, and I really respect that. There is a form of racing now that we call autocross that happens in a parking lot, and you just go around cones. And you have little to no chance of hitting anything. You don't reach any speeds over, say, maybe 30 or 40 miles an hour, if that. And it is hugely popular. And it is a way for those of anyone who, whether you have a race car or not, or a prepped car or not, or just want to try it, to learn car control, learn how to feel under and oversteer, learn how to stay in control, go fast-ish. And be safe. So I would say it's never too late, Dennis. Go for it.
Excellent. Thank you. I'm just going to share one other thing before we go. Let me just show you, let me get back to this for a minute. I want to get to, we do have, as Hillary mentioned earlier, we've got a guy next week. In fact, it's rare that they're back to back like this. It just so happened to be that. But next week we have AT, whose name is actually Elaine Transmontagne, I think is how you say that, but he says just call me AT. But he's going to talk about racing a Porsche GT3 that he owns, and he's got a bunch of other cars, and he also teaches adults like myself to race. And he happens to also be the CEO of a medical company on the side. And the story he tells me is that when he bought his Porsche GT3, his wife bought him driving lessons, racing lessons. So that's
Smart.
how I got into it. So I know, Jim, you're interested in seeing this one too. I look forward to having you
I'll be in the audience for sure. You can never, I don't think once you become a student of it, you never graduate. You're never really done. Even the best drivers in the world say that they still could use more experience. So I look forward to that. That'd be fun.
Well, I'm not surprised because, as you may know, I'm in the classical piano world myself, and even my teachers, who are some of the best teachers in Massachusetts, have their teachers too. I mean, there's always more to learn along the way, So I'm just going to put in the chat room now the link, if anyone wants to copy that, to AT's performance next week. So thank you again, Jim. This has been wonderful. I really enjoyed talking with you, and this was a great event. I think it's one of our best interviews ever. So. You made it happen. Thank you so much for coming tonight. Really appreciate it. Hillary,
well, thank you, Andrew. Thank you, Hillary. Appreciate it.
Yeah.
No, thank you for being here. And thank you, Andrew, too. Thank you, everyone, for coming. And I just want to thank everyone. Behind the scenes, we have the WSA, and they put out the newsletter, and they take care of the website. And we have the COA, they, participate at the Jenks Center too. So there's so many people behind the scenes that help us to be able to do this. So thank you to them too. And thank you so much for being here tonight. This was really fascinating. I need to get one of those collars and
Hans device.
I need one of those when I'm in the passenger seat with my I can see we're going to get some cones and put them out on the street now.
Perfect.
There you go. I would ask people people will get a survey in the email, so please fill that out. And thank you all again for attending. Jim, I'm talking to you tomorrow morning, as a matter of fact. So
sounds good, Andrew.
Everyone, have a great night, and thank you so much for coming.
Thank you, everyone.
Take care, everyone. Thank you.